Okay, so now we will do some exercise for continuous charge distribution. When a charge distribution is continuous, like the case of a uniformly charged thin rod or disk, we cannot use the summation. Instead, we must choose a differential element of charge dq. Let's determine the potential dV at P due to dq and then integrate over the entire charge distribution. Let us again take the zero of potential to be at infinity as we did for the calculation of potential due to a single point charge in the last lecture. Okay, now let's consider a thin non-conducting rod of length L. And it has a positive charge distribution, and this, because it's a rod, so the distribution is linear. To find the electric potential V due to the rod at point P, which is a perpendicular distance d from the left hand of the rod. Let's take your point P here, and it is at a distance of d from the end of the, this is I didn't draw it very straight, but it's a straight line, of course. Okay, now consider a differential element dx of the rod, a small element. The differential charge on this element would be this dx produces an electric potential dV at point P. The distance from point P to element dx will be taken as r. So r would be equal to, and this we can take this distance x, so it would be x square plus p square. Now, treating the element as a point charge make us able to use the following equation to write the potential dV. So we are taking this as a point charge. The potential at P due to the element depends on the distance r, this distance r. Since the charge on the rod is positive and we have taken V is equal to 0 at infinity, in that case dV would be positive. So to find the total potential V produced by the rod, this rod at point P, we will do integration along the length of the rod from x is equal to 0 to x is equal to L from left to right. So this would be, and here this becomes 0 to L. So now we will use this integral to solve it further. You can also find it in the Appendix E or 17 number in the book of Walker, Halliday and Walker, this one. So here this equation becomes lambda over 4 pi epsilon naught ln of x plus upper limit minus lower limit, you know, is very well. Write it here. We know ln of A minus ln of B written as A over B. So you can write it so here you can see that you can find out the potential for continuous charge distribution, and the case we discuss here is for a rod. Boy, you already have practiced this one when we solved it for electric potential for electric field distributions. we find out electric field for various charge distributions, I think, in chapter 22, and we already solved this, but in this time we are doing it for the potential. So this is the final equation, and for any linear distribution, if you want to find the potential, you can use this.